Welcome back to the final installment of the class. This week we're talking about the geology of the Death Valley area. Here's a shot looking, about southwest across Death Valley. That's Badwater down below. And the mountain range rising behind is the Panamint Range, and the snow-capped peak is Telescope Peak. That's almost 12,000 feet. It's 11,000 and change. And of course, Death Valley, where you see that playa, is below sea level. That's some pretty impressive relief. Well, this week we're going to discuss where Death Valley area is located, both geographically and geologically. Going to provide a succinct overview of the ages and distribution of rock units as well as we can. It's a little complicated in Death Valley. And then take a quick tour of some of the geological highlights. Well, a very familiar diagram to you by this point. Death Valley is located in the easternmost California area, and it's on the very western edge of the Basin Range. Now, here in this diagram, it's pretty cool because the bottom of Death Valley is below sea level, this digital elevation model is showing it in blue, just like the shallow areas of the ocean over here and the Salton Sea and down here in the Gulf of Mexico or the Gulf of California. Pretty cool, huh? So that's why it's not a lake, right? Of course it's not a lake. It's just showing you topographic elevations, and since it's below sea level, it shows up light blue. But we're directly in the basin and range here, and as we'll talk about in a minute, we're actually over here on the western edge where we see a lot of strike slip faults. Our familiar road map, okay, last time we were up here in the Mammoth Long Valley area, and we will have driven down Highway 395. Now, on our field trip, depending upon the weather, we'll either end up here in a place called Westgard Pass, which is in the White Mountains. That's if the weather is warm. Nobody up there this time of year except some bristlecone pines, and we'll camp out. If it's cooler, like it has been sometimes, then we'll end up down here around Lone Pine and be camping in the valley. So, but the one thing is the last day of the field trip, we'll take off coming down this way, turning towards the southeast, and then heading along this highway, which brings us into Death Valley. Now, there's lots of highways. This whole Death Valley National Park is this huge purple area. We'll actually be cutting through, making this little loop here, and then heading out of the park in the eastern park, and then ultimately coming down here near Shoshone, and that's in California, and then across into the garden spot of Pahrump, Nevada, and then finally into Las Vegas from the southwest. So that's sort of the shortest way to get back from over in the eastern Sierra. We have to travel through Death Valley to get to Las Vegas. So here is the Google map. Again, Long Valley up here and Mono Lake, what we talked about last time. There's the town of Bishop. Here's the White Mountains. This is about where Lone Pine is. This is the Sierra Nevada mountains with Mount Whitney, the highest point in the lower 48 at over 14,000 feet. And this is that highway that I indicated on the last map. And we come down here. This lake is Owens, and it's a dry lake bed now. And we come along, and here is that loop, right, that hump as we go up into Death Valley and around this mountain range and then down. This is the northern end right here of Death Valley. That's that large playa at Badwater. Now, this map or image doesn't show the entire road. I ended it here. We actually have to drive to the south a little bit. This is the Spring Mountain Range. You will remember the Spring Mountains as the thrust-faulted Paleozoic limestones on top of Mesozoic sandstone near Las Vegas. and then we'll drive around the Spring Range to the south and then into Las Vegas from the southwest. So Death Valley, we will not spend a lot of time there because we're really just transiting through the region on our way home, but we do have some time to stop and see a few things. Now, it's not the best time to visit in early May. In fact, if you want to really go do Death Valley right, you need to go in like January or February because the weather is heavenly, 70s, you know, that kind of thing. Here's that little loop that I was showing you on the larger maps, and as you come into Death Valley, the national park, from the west, we'll be driving in from Owens Valley. We drive over a mountain range here, and very steep downhills here, lots of basalts, lots of faulting, very dramatic views, and we go into Panamint Valley here. This is Panamint Valley, and then we climb back up Immigrant Pass, and we come up and over and then down into Death Valley. And so you're not seeing the topography here, but there's a large valley here, and then of course Death Valley here. And then we stop in Stovepipe Wells, and then we end up at these Mesquite Flat sand dunes. I'll show you the pictures of these at the very end of the lecture. Now what I wanted to point out with this diagram, and we'll follow this red road and then ultimately come out of the park on the eastern side. But if you come back here, there's lots and lots of roads to explore. And some of these are paved and many of them are unpaved. And that's because there's so many roads in the national park. It's because this area has lots of mining. And of course, the explorers and the miners put all these roads in, and you can still visit these places and need to use the roads, obviously, in order to get around. Well, like I said before, probably best to visit in the winter months since the hottest recorded temperature ever, and we mean in the world, was recorded right here in Death Valley, 134 degrees. That's pretty hot. Anyway, temperatures routinely get up into the high 120s and into even around 130 in the summer sometimes, so it's a place that you really don't want to hang out especially if you don't like the heat. But again, come back in January and the place is absolutely wonderful. I was there riding motorcycles in February this year, and it was in the high 70s and absolutely beautiful. Well, getting back to the geology now, if we remember this diagram from our structure lab book, we can see all those north to northeast trending normal faults that make up the basin and range. And as we get down in here into the southern basin and range, remember that to correlate or to compensate for this various amounts of offset, we're going to see lots of strike slip faults. And of course, this is the Walker Lane that I've talked about before, and the Walker Lane has lots and lots of strike slip faults in addition to normal faults. That separates it from the center of the basin and range. And of course, I've put this red circle in here showing you about the approximate position of Death Valley. And of course, Death Valley has a strike slip fault zone to the south, and it has a strike slip fault zone to the north. Both are right lateral strike slip faults, the same motion that the San Andreas fault has. And then between them are these normal faults. And when those strike slip faults offset, they create what's called a pull-apart basin. So zooming in a little bit more, we see the shaded area here is the Walker Lane. And the Walker Lane not only has lots of strike slip faults, it also has Long Valley, right? The big caldera system that we looked at last time. Lots and lots of gold mining along the Walker Lane because of the extra volcanism associated. And then it goes on up and merges with the Cascade Arc. Well, down here, this box, I put this in, and this is the Death Valley region, and enlarged over here, you can see the structural relationship of the northern Death Valley fault zone here, which is right lateral offset on the southern Death Valley fault zone. And what that creates is this sort of parallelogram pull-apart basin that shifts open laterally right? Moving sort of to the northeast, and one side is slipping away from the other. But again, it's driven, right, and accommodated by these right lateral strike slip faults. Along the western side, you see a very big offset, but you don't see a lot of different, as you'll see in the diagrams I got in front of you here. That over here we don't see a lot of offset of a dramatic offset of ages of rock units. But over on the eastern side, this side, we really see some interesting rocks. And this is the location of these turtlebacks. This is the Badwater turtleback, the Copper Canyon turtleback, and the Mormon Point turtleback. And these turtlebacks are metamorphic core complexes where old Precambrian rocks have been pulled out from underneath, and they're offset with Cenozoic igneous rocks. So in the rocks that we've talked about, that's like taking the bottom of the Grand Canyon and offsetting it with like the top of Zion. I mean, it's a pretty impressive offset. Here's a beautiful false color Landsat image of the Death Valley area and surrounding parts. There, I've superimposed the same pull-apart basin with the right lateral strike slip faults to sort of put it in perspective for you. There's the western side with all of these alluvial fans. There's the eastern side, and these are the turtlebacks. The darker rocks are the older Precambrian rocks that are being pulled out from underneath and offset now with the Cenozoic younger rocks. If you've had structural geology, these are detachment faults. There's lots and lots of mylonites at their boundary. You see ductile deformation in the footwall. You see brittle deformation in the hanging wall. This is Panamint Valley. This is the direction we came in from, through Panamint, and then around here and over this. There's that hump in the road that I talked about. Anyway, this is Panamint Valley. This is Death Valley. Up in here we have Saline Valley and the Racetrack, and this is Saline Valley, and this is the Racetrack up here. Over in this area is something interesting. This, I've mentioned before, is Yucca Mountain. And these little black dots here are the young volcanism, and that's the reason I had a job for so many years at UNLV. These young volcanoes are coming up along the same faults that cut Yucca Mountain. Of course, if you buried nuclear waste in this mountain, one of the potential threats was the eruption of another volcanic center. Pretty cool. One of the things I wanted to draw your attention to was look at the dramatic differences in colors here, and each one of those will be a different rock type, some older, some younger, sedimentary, igneous, metamorphic. A big difference from when we were over on the Colorado Plateau, right? And of course, the Colorado Plateau has simple stratigraphy, rocks stacked on top of each other, older at the bottom, younger at the top, much simpler. And of course, it's why we went to that part of the world first, and then we sort of worked our way to the west. And of course, Death Valley is a very complicated area. Now, it has the same rocks with the same structural and geologic histories that we've already talked about. Nothing has changed, as you'll see. But when you scramble all this stuff up together and you thrust fault it and you have intrusions and you normally fault it, plus you don't have hardly any vegetation to cover anything, it can make for some beautiful but complicated looking outcrops. All right, so let's take a look at the geologic history quick. I've cut this into two parts so that it's visible. Here's the Precambrian and Paleozoic geologic history. Now, you should remember what was happening here. If we go back into the Precambrian, right, we have some, this says no rocks older than 1800, that would be 1800 million. Well, those are the same rocks that we saw at the bottom of the Grand Canyon. Those are metamorphic rocks and igneous rocks. And then on top of them, in the Proterozoic part of the Precambrian, we have sedimentary rocks. And those are the same as the sedimentary rocks in the Grand Canyon that were tilted, right? Tilted is part of that rifting event. Now we didn't see these rocks, these old Precambrian rocks, further to the west because remember that North America was rifted prior to the formation of Pangaea. And so this area, we are far enough east that this area is still that old, has those old Precambrian basement rocks. And then on top of them, after the Precambrian, it's just the same story, right? Of Cambrian, Ordovician, Silurian, Devonian, Mississippian. All through here, it's basically sediment deposition. We're a little further west than the Grand Canyon, and so we see more marine deposition, but there are terrestrial units that come in and out. But that's basically what's going on during the Precambrian and Paleozoic, is just deposition. When we move to the Mesozoic, okay, the Mesozoic starts with marine deposition, but here in the Jurassic, the seas withdraw because now you're going to start to form the mountain ranges, right? We have an arc, we have an orogeny, and this place starts to get wadded up and fold. Then plutons get intruded in the Cretaceous. That's going to create all of those granites that we're going to see in the Sierra Nevada mountain range. It's also going to cause thrust faulting further to the east. These are the large thrust faults we see throughout Nevada, and we see this deformation as far east as St. George. Now, later on in the Cenozoic, the place gets sort of planed off, right? It forms a big unconformity, so the older rocks get sort of smoothed out, and then after that we start to see the onset of major extension. Things start to pull apart. Things are going to start to tilt. You're going to start to get the eruption of volcanic rocks, whether they're basalts or whether they're more silicic. And then that leads up to the formation of Death Valley itself. But notice here in the Pleistocene, right? And the Pleistocene is roughly the last couple of million years up to 10,000 years ago. And Death Valley was filled up to 600 feet deep with a large lake. No ice at this latitude, but a heck of a lot of rain. So all these big valleys of the basin and range are getting filled up with water. And then finally, the last things to occur is continued deformation, continued volcanism, and pretty neat here. I'm going to show you a picture of Yuba Hebe volcanic field and Yuba Hebe crater. Did you remember all that? Remember? That's the stuff we've been talking about for the last 14 weeks. Well, here we go. More Death Valley geology. What do I have to say? Well, this is a geologic map showing the various distribution, at least simply, of these different kinds and packages of rock. Now, the late Precambrian Pahrump group, these pink ones, these are going to be like down here. This is these rocks here, over here. This is in the Funeral Mountains. This is the Black Mountains. Then the blues, that's all Paleozoic rocks, right? So same age as like the Grand Canyon kind of stuff. So those are all Paleozoic. And then we see Mesozoic intrusive rocks. That's the intrusions that are going on during that large orogeny. And then there's going to be some Cenozoic intrusive rocks as well. And they're not that easy to tell apart. You've got Cenozoic granites basically and Mesozoic granites, but you also have volcanic rocks. So you can see things are scattered around here pretty well. And then of course the valleys are all filled with evaporites, lake deposits, gravels, that kinds of things. I showed you this cross section in an earlier class, but this is over to the west side of Panamint Valley, and we'll actually see something about like this when we drive in from the west. But this one outcrop, this one panorama pretty much shows the relationship of everything we have learned. So this view is sort of north, right? There's over here, this is the Panamint Valley, and there's the Panamint Range over here. But anyway, what we see is folded Paleozoic rocks, and these very easily could be folded and thrust faulted, right? So deposition of the Paleozoic rocks, then squeezing and faulting, and there's some faulting right in here you can see. Then they have an unconformity, and they're cut by Mesozoic granites. Then Cenozoic basalts are erupted, and you get normal faulting of that whole package. So that's pretty much our structural geology history of the entire western U.S. in a nutshell. A couple of cool pictures just showing the complexity of these folded and faulted Paleozoic and Precambrian sedimentary rocks. Pretty neat. Here's a view looking from Dante's view. This is on the east side of Death Valley. You're looking down at Badwater there, right? Badwater is where it's the lowest point in Death Valley, and that's 282 feet below sea level. There's Telescope Peak and the Funeral Mountains, and look at all those alluvial fans. Now, there's a reason that you have so many alluvial fans is as this valley gets pulled apart, the bottom is dropping out so fast that the range is just, they have these very steep slopes. It's over a mile from where this picture is taken down to the bottom. That's vertical difference, not horizontal difference. So there's quite the gradient when things start to flood down. So you're going to see lots and lots of alluvial fans, and of course in this climate, flash flooding. Now, imagine that the bottom of Death Valley here was filled up to 600-foot depth, right, with a lake during the Pleistocene. That would have been pretty impressive. You could have cruised from north to south, right, in a lake. And if we look carefully on the margins here, you'll be able to see ancient shorelines. Now, after you get done watching this video lecture, I've got a short, a little over 6-minute field trip to Death Valley that I put online for you to watch. And in that video, he's got some really good images of those shorelines. Here's another shot looking on the west, or excuse me, the east side of Death Valley. There's Badwater down here. This is the Black Mountains. These are those turtlebacks, right? And this is about the area that we're looking at, looking from the south to the north, and you're seeing the bottom of the valley, right? And then over here on the eastern side, you're seeing various old Precambrian rocks. And if we got up close to these, you'd see that they are ductily deformed, and then there's a fault, mylonites, and then on top of them will be younger, much younger, and brittly deformed Cenozoic volcanic rocks. Really neat. And that's not too hard to find off the road. We usually don't have time because we're on our way back to Vegas. Here's a couple of cross sections. They both show the same thing. They are looking from west to east, and this one just has got more vertical exaggeration, and the idea is that you have these tilted normal faults which are tilting the ranges, and you're opening up Death Valley. It's not even on both sides, right? It's got more offset on the east side than it does on the west. Here is a much more realistic picture, but I wanted to show this because you can see out here in the center, these would be playa lake sediments and evaporites. And of course, that's why the 20 mule team's there, right? Going after those evaporites. And then these would be alluvial fans that are coming in, right? The facies coming in from the ranges as they move up and the bottom drops out. You keep dumping these gravels in from both sides. So you've got valley fill as the lighter colored material, older sediments that have been more thoroughly faulted below them, right? And then of course the bedrock, which here is everything, Paleozoic, Mesozoic rocks. Well, beautiful views, again, because it's a desert, and because you don't see a lot of vegetation, lots of wind going on, we have sandstones around, and of course those sandstones lose their sand, and the modern winds whip them up and blow them into modern dunes. So you're going to see a lot of neat sand dunes, especially in the northern part of Death Valley, and we'll drive right by these, and these are the sort of mesquite dunes. These are famous They're beautiful. You see lots of pictures of them, lots of tourist pictures of them, but they were also the set for several of the Star Wars films. And again, when they needed good sand dunes and they needed a close locality with dramatic backgrounds, these sand dunes filled in for instead of having to go all the way to North Africa. And you'll be here too. Well, let's take a look at two other notable features in the park. Now, we won't go see these, but they are easily visited and really worth the trip if you get a chance. The first one is the Yuba Hebe volcanic field, and Yuba Hebe, I just love that name, right, is named after this large crater. This crater is 600 feet deep and almost a half-mile across, and it was blasted out when magma came up, hit groundwater, flashed that groundwater to steam, and basically exploded it, just like if you threw water into a hot pan. And this occurred, they think, as little as 300 years ago. And you can see it's not just the large crater, but there's other craters as well around here. Pretty neat. Anyway, that is called a maar, and you know, it blasts itself out of the local rock. Pretty neat. That's up in northern Death Valley. You got to take a little side trip up by a place called Scotty's Castle. Another famous location to visit is the Racetrack. And the Racetrack is a playa, and on this playa you'll see these long skid marks with a rock at the end. No footprints, no other indication, nobody pushed these things, but what it looked like was the playa would get wet and the wind would push these rocks, which of course is impossible. Well, just recently, researchers have determined what the cause was, and it turns out that when you get the right conditions, the playa has to be wet and it has to freeze. And when you get this ice, it just the right set of conditions with some wind, and these rocks can be pushed along as this stuff, the ice sort of gets heaved and pushed. Anyway, pretty cool, another neat place, yeah, that's it. Okay, so that's pretty much it for the class. Now I want you to go take the quiz, but before you take the quiz, watch that short field trip because I'll have some questions on the quiz from both that and this lecture. And I really hope you learned something about the Southwest. I love this place, you know that, right? I know I learned something because as I researched and tried to put this material down, you know, I'm always learning something new myself. Now, of course, 10 people are accompanying me in a very short time. We're going to go on in this area and take a close look at this stuff. But if you don't get a chance to go on the trip this year, maybe you can go on it with me the next time I lead it. Or come visit the place on your own. So just to let you know, we should be going to Hawaii next year. So if you didn't make it on this year's trip, see me early for a slot on next year. Anyway, I had a great time doing this. Take your quiz, and that's it.